Hello, my name is Brent Thompson. I'm a student in the Computing Technology and Software Development program at Valencia College. I'm also an assistant in solar research here at the Florida Solar Energy Center. I study solar panels, and for this project I've collected a little bit of data to plot, and I've also created some metadata parsing scripts to give researchers the data sets that they need to perform their analysis. A little bit about the project. This is a full stack software for exploratory data analysis. I'm using SQLite for the back end to persist the data and store all of my metadata, and I'm using Python for my front end. I'm using Shiny. For tools and languages, like I said, I'm using SQLite for the database. Everything is normalized around module IDs. Each module, we perform several different measurements on it. And as far as the Python, I've got a full project built with Shiny, and some important libraries are pandas. For object relational mapping, I'm using SQL Alchemy. And for implementation, I'm using the UV Python package manager to handle all the dependencies and environment solving. And this software is designed to run on databases here at FSEC, but it could be used for anybody with time series data that need a reactive plot. I use the program through the local web browser, and some time was spent on trying to integrate the Postgres, but I ran into too many networking issues. I realized that using local databases is perfectly fine. It doesn't run into problems of personal identifiable information that can't be stored in the Postgres but is needed for local data analysis. Alright, now I'm going to switch over to the actual program and demonstrate its capabilities. This is the Data Explorer. Got a nice home page that shows you a little bit about each tool. First tool is just viewing data. This is very similar to an SQLite viewer. So here we could just see all the metadata and data about each module, and this is something that my metadata parsing scripts are creating. The most useful tool here is the search modules function. A researcher can come in and do their experiments, and when they need to pull the data for their analysis, it's all in one place. So this is for current voltage measurements. This is for pseudo-IV, electroluminescence. The important things are you have all your metadata as well as the file path. And this is useful for machine learning and image segmentation. A lot of the times the researcher just wants a data frame, and then they can perform their analysis by referencing the file. You can add as many modules as you want here. You can also search by serial number. And once you've got all the modules that you want, you can download it, and it will automatically produce this zip that has each of the tables from the database as a CSV, as well as a README that has some metadata that includes things like the cell technology, the interconnection scheme, and how many records you have total. For visualizations, created this reactive plotting tool. Here you can just add any module you want. You can add many modules. And then you select the parameter that you would like to plot. Here we can see there's an outlier right off the bat. This is not a good measurement. This is something that ideally is cleaned from the data set before it's used. We'll just go ahead and skip past 2018. Let's go with 2020. Alright, so right there, you can start tracking how the fill factor load of the module has changed over time. You can also use shunt resistance. So now we have another outlier here. That'd be good to check out and see what happened then. And like I said, this can be used for any number of modules. And it helps to get more granular with the time. There's another outlier. Now, some finding and results. Generating the experimental data sets. It's done 99% faster than previously. In the past, it would take me at least a half hour or an hour to generate these reports that have all the different tables. Human error is reduced to just the module selection screen. So there's still some room for human error, but everything else is fully automated. And also for plotting. This was a manual process of opening up an IDE and importing matplotlib and defining your plots. We ran into problems with reproducibility for some graphs, and some people don't want to learn the Python to do it, so having a tool to just quickly generate a graph, save the image, it's quite useful. And again, identifying those outliers and bad measurements helps a lot, especially as measurements are being taken. People can identify it. Some of the technical challenges I faced were attempting to integrate the Postgres. I realized that there were some firewall and networks issues that exist with UCF. And I also realized that I need to have all of my metadata present for the experimental data sets. And when we push to Postgres, it strips away all that data. Another big issue I ran into was the Python versioning, and that's what led me to use UV. It kind of packages everything into one spot. And you can manage everything through a TOML file, similar to a POM XML in Java. Biggest successes are having the ability to plot measurements reactively and not having to open up an IDE or deal with any code. This has greatly increased the rate at which we can generate these plots, and it allows a researcher to stay in their measurements and not have to go back and forth. It's less context switching. And again, identifying those outliers quickly is very helpful. My biggest disappointments were not really being able to use the Postgres. That's where most of my development is at these days. And for the plotting features, I realized there's a lot of quality of life things that would have been nice. For example, it'd be good to be able to hover over a point and see that file. That way I can track it down and delete it or clean it. So those are my disappointments. If I could do this project over again, I would have spent more time on the visualization. It would be good to have more customization options. It'd be good to be able to add more words to the plot before saving it. Pretty much everything that's needed is automatically generated. Sometimes a researcher wants to add more things, so being able to do that would have been nice. And I would have explored other frameworks like Streamlit a little bit more. I went with Shiny just because it was a new technology I wanted to learn. And the process for starting the program is just 2 commands in command line, but there is always the option to create an exe, an executable. If I could do this project over again, I would have started sooner, and I would have had my milestones completed earlier. Thank you for your time. Thank you, Professor Corey Luang, for giving me the time and encouragement to get this one finished. And thank you to Material Data Science and Stockpile Stewardship for funding the work. And that's it.